Ever since Donald Trump took office in the end of January, rumors have been swirling around the nature and operational issues around Starlink and American surveillance assets. As late as last week, the Polish foreign minister came out and said that he expects that Starlinks bought by Poland for Ukraine would remain operational. Elon Musk's childish response, calling the foreign minister of one of the US's greatest allies a small man, tells us everything we need to know. The fact that little Marco Rubio later supported Musk rather than Poland shows that it is time Europe take care of its own satellite communication needs. I'm Tuomas, a former officer in the Finnish Defense Forces, and in today's episode, the 7th in our series, we're going to see how Europe's move to be self-sufficient in military matters, especially satellite technology, could really affect the American economy. We'll discuss why it's important for Europe to cut its reliance on systems like Starlink and other American satellite tech. We'll examine satellite technology, communications, space operations, and much of Europe's urgent need for a complete revamp of these sectors, and how a lot of this has already started taking place in the European Space Agency, with Eutelsat and within the now many different projects going on in Europe. First, let's dive into a topic we touched on in the introduction: satellite communications, specifically satellite internet providers. It's estimated that Ukraine uses around 20,000 Starlink terminals, primarily funded by the governments of Poland, France, Britain, and the Netherlands. However, recent events have raised concerns about the reliability of these services. Poland's foreign minister highlighted issues when Elon Musk, the CEO of the company, seemingly wanted to use these services as leverage to push Ukraine to an unfair settlement. Poland alone sponsors about 20,000 Starlink subscriptions for the Ukrainian armed forces. Any interruption or manipulation of these services could spell the end for Starlink's presence in much of Europe, not just because of consumer sentiment, but also because influential politicians have reached their limits with these tactics. These terminals are crucial for communications, drone targeting, and ensuring that those near the front lines have consistent internet access. It is estimated that Starlink has over 450,000 subscribers in NATO-allied European countries alone, and a further 150,000 users in Ukraine. This accounts for anything from 15 to 20% of Starlink's customer base, and if you remove government contracts from these figures, it is close to 50% of their civilian customers. So, what can Europe really offer up to help negate a likely Musk sabotage of these systems? One of the big success stories of this year within the European telecommunications scene is Eutelsat, which is essentially a merger between France's Eutelsat and British company Oneweb. This company is the only worldwide entity which can challenge Starlink's low-orbit satellite coverage. The company currently has 630 low-orbit satellites against Starlink's 6,000. However, it is important to emphasize that Starlink serves clients worldwide, while Eutelsat, which is owned in part by the British and French state, focuses primarily on the European and African market. Eutelsat already offers internet to Ukraine's government and state services. However, deploying terminals into the field would likely be a bigger task. One terminal for big demand, like in a city, costs as much as 10,000 euros plus a subscription fee, and there are a lot fewer terminals available than with Starlink's. Oneweb does have some smaller options which are more affordable, and France and Britain have already put factories into gear to create cheaper and more plentiful terminals should Starlink be used as a negotiation card. And word from Ukraine is that quite instrumental hacker groups are working right across the globe to refit or jailbreak receivers to work with Eutelsat signals. In medium orbit, Luxembourgian SES is the king of worldwide satellite communications. While generally having satellites in mid-orbit means slower bandwidth, they have a large market share in this space and have proven in field tests in the Philippines that they can achieve 500 megabytes per second download and 80 megabytes per second upload speeds. Spanish Hisdesat and Hispasat are two companies that could contribute to the European initiative to aid Ukraine, albeit with fewer satellites than the aforementioned companies. But I think, as with all initiatives coming out of Europe these days, every little counts. The Spanish Navy and military already uses their combined 12 satellites for communications and internet connection, and could likely also contribute. The EU, which seems to have finally woken up to the reality, has pooled 10 billion euros and contracted some of the heaviest developers of satellites such as SES, Eutelsat and Hispasat, as well as the European Space Agency into its IRIS-2 program. The plan is already well underway, and they aim to have 290 low and medium orbit satellites in place by 2027, which in my opinion is the way to go for Europe. We need to start thinking strategically in order to secure our communications future, and having all these smaller companies contributing to this large program will bring the experiences from all their programs into one. Last but absolutely not least, Project Bromo is an exciting new initiative led by Airbus, Thales and Leonardo, designed to enhance Europe's satellite capabilities. This collaboration unites many of the top aerospace firms in Europe who have a proven track record. Bromo is set to rival major projects like Starlink and IRIS-2, although much of their plan is still kept confidential. Inspired by the successful collaboration model of MBDA Missile Systems, who famously makes the Storm Shadow, Taurus and many other very successful weapons variants, this project aims to produce cost-effective satellites for low orbits, potentially transforming the European satellite industry and likely becoming a credible alternative to Starlink in the long run. So, before we move on to imaging systems and launch capability, let's summarize. In total, European companies currently have somewhere along the lines of 700 communications satellites in orbit. However, with the addition of the IRIS-2 program and a future Project Bromo deployment, this number will likely exceed 1,400. What I'd ideally like to see is more cooperation, rather than heavyweights like Airbus, Thales and Leonardo going their own way. They should be offered to be included in the pan-European IRIS-2 program. Both parties would prosper from the added financial weight on the EU side, while IRIS-2 could greatly speed up if it received the production capacity and know-how of the three companies mentioned. Europe's space launch capability represents a crucial component of its broader strategic autonomy and scientific advancement. The continent's pursuit of independent access to space is facilitated through a cooperative model that pools resources, technology, and expertise from several member states within the European Space Agency and individual national programs. The primary hub of European launch activities is the Guyana Space Center in French Guiana, a facility best known for launching the Ariane series of rockets. These rockets, particularly the Ariane 5, have been instrumental in deploying commercial, scientific, and exploration missions to orbit and beyond, cementing Europe's role in the global space market. Several European countries have their own space launch capabilities or are significant contributors to pan-European efforts. France, as a leading member of ESA and home to Arianespace, plays a pivotal role in the development and operation of the Ariane launch vehicles. Italy also boasts impressive capabilities, highlighted by its participation in the Vega launcher program, a lighter rocket designed for smaller payloads. The Vega rockets are primarily developed by the Italian Space Agency and Avio, an Italian company, demonstrating Italy's engineering prowess and commitment to space exploration. Germany's contributions to European space endeavors cannot be overlooked. As one of the largest financial contributors to ESA, Germany invests in various aspects of space technology, including the development of rocket propulsion technologies and satellite applications. While Germany does not have its own launch site, its technological contributions are vital for the success of European launches. Additionally, Spain, while not possessing its own launch vehicles, is integral to the European space sector, hosting several key ESA facilities and contributing to the development and construction of space systems and components used in various missions. The UK is renowned for its expertise in manufacturing small satellites, with companies such as Surrey Satellite Technology, Open Cosmos, AAC Clyde Space, and hosting many of Airbus's main satellite production facilities. These companies are at the forefront of producing compact yet highly capable spacecraft. The UK Space Agency actively collaborates with the European Space Agency, making significant contributions to various missions and projects. Within ESA, the UK has played crucial roles in major projects, including the ExoMars rover, which is partially built in Britain, and the Galileo satellite navigation system. Looking towards the north, Sweden has established itself as a significant player in the space sector through its S-Range Space Center located near Kiruna. Although primarily used for suborbital missions and satellite tracking, there are plans to expand its capabilities to include orbital launches, especially for small satellites. This initiative underscores a growing trend within Europe to develop facilities and technologies that cater to the burgeoning small satellite market, which demands more flexible and cost-effective launch options. One thing I'd say that Saab should likely reconsider is its involvement with SpaceX, seeing as Elon Musk is disliked by nearly 90% of the population in recent polls. Lastly, Norway, while smaller in scale within the European space sector, holds a strategic position with its Andøya Space Center located just north of the Arctic Circle. This launch site is particularly well suited for satellite launches into polar orbits, commonly used for Earth observation satellites. Norway's involvement in space exploration includes significant contributions to satellite technology, particularly in developing components that withstand the harsh conditions of space. The Norwegian Space Agency collaborates closely with ESA and participates in several key science missions and satellite operations. The development of the Andøya spaceport for orbital launches, planned to commence operations in the near future, marks a significant step in expanding Norway's capabilities in the space industry. To summarize Europe's launch capabilities before we move on to imaging satellite technology, it is once again evident that Europe has a lot of capability, but as with its military industry, it is often spread right across the continent. The European Space Agency is a step in the right direction. Nonetheless, like with military technology, it would be smart for Europe to streamline these processes, ensuring that as a continent, we try to put security first and then market competition second. In an ever-changing world, it is possibly also smart to start thinking about getting a mainland European launch site up to the standard of the one in French Guiana, because in a conflict scenario, this could be cut off. With an ever-unstable US president, it would likely stretch the British and French navies heavily if they had to protect it. Now, on to imaging technology. One of the big issues that Ukraine has had to deal with in regards to depending on American satellites for their intelligence is, as we saw with Maxar just a few weeks ago, where American politicians essentially denied Maxar sharing images with Ukraine. This sort of unreliability is something Europe as a continent cannot depend on, which is why it is great to see that we've also got great companies and alternatives within this sector. Airbus stands as one of the largest entities in the field of satellite-based geospatial mapping. The recent geopolitical events involving Ukraine highlighted the critical role of satellite intelligence. When US intelligence support was used as blackmail, it inadvertently provided an opportunity for European nations such as France, Germany, and Great Britain to demonstrate the capabilities of Airbus' advanced geospatial mapping systems to Ukraine. These events have allowed Ukraine to increasingly rely on Airbus for its superior satellite imagery solutions. Airbus boasts an impressive fleet of Earth observation satellites that excel particularly in multi-spectrum mapping, where they are reportedly superior to competitors like Maxar. This capability is crucial as it provides more detailed and versatile data, enhancing applications in military planning due to being able to look for, in example, radar radiation or minute heat signatures. The company's satellites are equipped with cutting-edge technology capable of capturing high-resolution images across various spectral bands, which not only provides standard visual imagery, but also gathers data from infrared and other parts of the spectrum, which in recent days has proven extremely deadly for a lot of radars in Crimea, as Ukraine's boat-launched FPV drones have taken apart air defenses night after night. Secondly, and yes, I know that this is a Finnish company and Finns don't like to brag about ourselves, ICEYE has proven to be a very useful provider of imagery to Ukraine. They are known for their cutting-edge synthetic aperture radar technology, which has played a significant role in the Ukraine war by providing crucial satellite imagery and data to support military and humanitarian efforts. Their SAR satellites can capture high-resolution images, regardless of weather conditions or time of day, making them exceptionally valuable for continuous monitoring and intelligence gathering, when an example Maxar would be unable to deliver due to cloud cover. Throughout the conflict, ICEYE has supplied up-to-date imagery that has been pivotal for tracking troop movements, assessing damage, and planning humanitarian aid operations. The ability of ICEYE's satellites to penetrate cloud cover and operate effectively night and day has provided Ukrainian forces with a persistent surveillance capability that is less affected by the environmental limitations that hinder optical satellites. Thirdly and finally on this list are ESA's Copernicus and INSPIRE programs, which are two geospatial initiatives that monitor the Earth from space for environmental purposes. The Sentinel satellites, which form the backbone of these programs, are also well suited to contribute to defense matters, though this would require some adjustments to the programs by the EU. A notable strength of both Copernicus and INSPIRE is their robust data capacity, enhanced by AI technologies. This advanced AI is utilized to detect environmental changes and emergencies such as wildfires and oil spills. Importantly, the same technology could be adapted to identify military assets, such as a concealed radar installation within a Russian air defense system, showcasing the dual-use potential of these environmental monitoring tools. In conclusion, the evolving landscape of European satellite capabilities underscores a critical change of direction towards self-reliance and strategic autonomy, which now has been supercharged by the US using satellite technology as a blackmail tool towards Ukraine. The necessity for this shift has been starkly highlighted by the operational challenges of being reliant on a nation which now appears to be perfectly happy with extorting and threatening allies. As Europe navigates this complex terrain, the integration of military and civilian space technologies becomes increasingly important. Being able to use civilian satellites for military purposes going forward will be extremely urgent. Looking forward, the collaboration among European nations and private sector entities will play a pivotal role in advancing the continent's satellite and space capabilities. Initiatives like Project Bromo and the expansion of the IRIS-2 program is just the beginning. By pooling resources, technology, and expertise, Europe can ensure that its satellite infrastructure is robust, versatile, and most importantly, under its own control. Let's not forget, the Germans invented the rocket as we know it, a Ukrainian invented the first satellite and spaceship, an Italian invented the improved telescope, and together Europe has what it takes to be a peer to anyone within the space race. We just need to start pooling our resources more. If you want to see more, I've added a playlist for this series which now has over 2.2 million views in the comments and description. As always, I hope you have a sunny, restful weekend wherever you are. As we say in Finland, hyvää viikonloppua!